Hi everyone. This series of videos is going to take you through page 13 in the packet, which is more review and practice of sequences with word problems. Just like the videos for page 12 in the packet, there's not really new information presented on this page, so you probably could, in theory, use some of the videos from other playlists, like the playlist that goes into detail on page 12 or pages 10 and 11 to see if you can get some much needed notes in case you want to do some of these without watching these videos. If you feel like you already understand the basic ideas, then I think honestly you can probably get away with doing all of the problems on this page without any videos at all. These videos are here to help if you feel like you're not sure about something specific, or if you feel just more confident when you go along with the videos, but these are not mandatory to watch, nor will you hear any new teaching in any of these videos. This is me just talking through my thought process as I do the questions, but not really sharing anything that you wouldn't have already learned from a previous video or from a previous lesson. So as always, use your best judgment about how much you want to watch. If you want to pause or eventually stop or fast forward something, feel free to do so. Now in question number 3, I'm going to do exactly what I've done with all of the word problems up to this point. I'm going to read the question, I'm going to identify whatever numbers they seem to be giving me in the question, and then I'm just going to try, if I can, to answer each part so that I can sort of process piece by piece how this translates into a sequence equation. The first thing I'll do is read the question and highlight anything that seems important. For example, if at the top you read the first sentence, it says there are currently 400 quarters in a fountain at the park. Now, the word currently is synonymous with another word that you've heard a lot in these problems, and that's the word initially. Currently and initially are kind of similar in this context, so I can assume that 400 must be what we've been calling the initial value of our sequence. The initial value is always really important because the initial value is usually part of the equation that we're going to use, and since the equation does a lot of the work for us, we need to identify that initial value right off the bat. So we're going to benefit here from saying initially we're going to have 400. I know exactly why I'm going to use that 400. Now it says in the next sentence, every day the amount of quarters in the fountain doubles. Now the word double is actually a math word. It just doesn't necessarily seem like it. So if you weren't sure what to do with that information, let me give you a hint. The word doubles is really another way of saying multiply by 2. You probably know that already, but if you wouldn't have written those words, you may want to consider doing that, because if I am multiplying by 2, that implies I have a multiplier, and we know that the multiplier is another important part of a sequence equation. So in theory, I have a couple of pieces of information that are going to give me some hints about how to answer this first question. In letter A, it says, would this pattern be considered arithmetic or geometric? As you probably remember, arithmetic is all the sequences that are adding or subtracting, and geometric is all the sequences that are multiplying or dividing. So if I think logically, I know that in the original question, when they told me doubling, doubling is synonymous with multiplying by 2. So since I am multiplying something, that must mean we are geometric. Now, because it's geometric, I know that there's going to be an equation and a structure of the equation that I can use to help me see the number of quarters that we have. If you look back at your notes from some of the previous pages, you may remember that we talked about a structure for a geometric equation. The geometric equation always starts with T of n equals, and then we say initial value, I'll use I for initial, times multiplier, I'll use M for multiplier, to the power of n. That's always been the geometric equation structure. And since I know that this is a geometric problem, I know that I can use that structure. So I'll start with t of n equals, and then I'll substitute the information from the question. Initially, or currently, we have 400 quarters, so there's my initial value, 400, times the multiplier, doubling was multiply 2 to the power of n. Make sure that you write your n as a power. It should look like an exponent, not a standard size n. Kind of lift it up like that in a little subscript, tiny font. Now this equation should, in theory, help me answer questions C, D, and E. So I'm going to leave it up to you for a second. Look at the rest of the questions in number 3, C, D, and E, and ask yourself, do I know how to do these questions with the equation? Can I simply plug in information into the equation and figure out the answers? Because if so, you might not need any more guidance, and the equation might be all you need. If you feel like you need more guidance and you're not sure how to use the equation, the next video will go through these questions. But make that decision for yourself. And if needed, use the equation, solve letters C, D, and E on your own, and skip the next video so that you can get the answers and check with the answer key and save yourself some time.